Hello students, in this video we are going to discuss about gravitation. It is common understanding that it's Earth's gravity what keeps you on the ground, what keeps all these things on the ground, and what makes objects or things fall towards the ground. It is gravity of the Earth. And you know that already you have studied that the gravitational force is one of the fundamental force in the nature, and it is weakest force, and its range is infinity. It's a long range force, and the source of the gravitational force is mass of the body. It's mass. Okay, and Newton observed all these things, and he come up with this law of gravitation, and we call this as Newton's universal law of gravitation. Why universal? Because this law is applicable for every object in this universe. Okay, if that object has mass, then this law is applicable. This is a very simple law. So it states that every body in the universe attracts every other body. For example, there is a chalk piece, two chalk pieces are there. So this body attracts every other body with a force which is directly proportional to the product of their masses. Directly proportional to the product of their masses and inversely proportional to the square of the distance between them. For example, here, if you are standing here and in front of you there is a car. Both of you have masses. And because of this mass, this car is exerting gravitational force on you, and you are also exerting an attractive but gravitational force on this car. And because of that, there is a gravitational attractive force between you and the car. It's a very simple force, very simple law this one. That is Newton's universal law of gravitation. Let us solve the Newton's law of gravitation in the form of equation. Okay, to do that, we have to consider two bodies of mass m1 and m2 separated by a distance r. So consider two bodies of masses m1 and m2 separated by a distance r. So there are two bodies. One, its mass is m1, and the other body, its mass is m2, and they are separated by a distance r. Okay, and according to Newton's law of gravitation, the force of attraction between these two bodies, So let me define the force, that is if F be the force of attraction, between the two bodies, then according to Newton's universal law of gravitation, this force of attraction, that is gravitational force, is directly proportional to the product of their masses, that is m1 into m2, and this force is inversely proportional to the square of the distance between them, which is r. R is the distance between the two bodies. So that's why this F is inversely proportional to the square of the distance between them. And if you combine these two equations, you will get F is proportional to m1 and m2 divided by r square. And when you remove this proportionality sign, you will get a constant called universal gravitational constant G. So according to Newton's law of gravitation, this is our force. This is the force of attraction between two bodies of mass m1 and m2, and they are separated by a distance r. And now this G is called as universal gravitational constant. constant, and the value of G is 6.67 into 10 to the power of minus 11, and its unit is going to be Newton meter square per kg square. Okay, so this is the force between the two bodies whose mass is m1 and m2, and they are separated by a distance r. Very simple equation. F equals to G, where G is universal gravitational constant, and you know the value of the G, and then m1 into m2 divided by r square. And one more thing, G is a universal constant and it is a scalar quantity. Okay, right.